Okay, start reading here. So at the beginning of 2010, a landfill contained 1,400 tons of solid waste. Okay, I don't really know for sure, so I just kind of circle numbers. Tons is important. You've got tons of waste, period. I always agree that the period, just make sure I'm understanding it. But go slow, it's way better than going fast, I guarantee you. Fast does not help anybody. You just logically figure out the problem. The increasing function W, that could be important. So W is increasing, models the amount of solid waste. Hey, that's crucial. This is an amount. I'd write that down. It's not a rate. W is an amount. Planners estimate that W will satisfy the differential equation here. Okay, so now what I have is I have W, the amount, this is the rate. That's the rate at which W is changing. Questions? So let's see. W is measured in tons, I already had that figured out. Years is the time. That. Oh, since 2010. So that makes it easier because they're going years from 2010. So year 0 is 2010. I might write that down. So year 0 is 2010. Questions from anyone about the reading? So go to part A. Part A says use the line tangent to the graph of W. So I'm going to draw my favorite picture. W is increasing. This is W as a function of time. I'm supposed to use the line tangent to W. Just scratch word. Yeah, that's just worry about. No, just this is just for me to remember. Okay, so no. So I remember this is going to be y equals m x minus x1 plus y1. Use the line tangent at t equals 0, so I write that down. So I need W at 0. They told me that. It's up there, times 0, 1,400. To approximate. Okay, so I can't use a line tangent to approximate something unless I have the line tangent. So I need this line. This is W. I can find the slope of W using the formula for the slope of W. So I use that. I say dW over dt when W is equal to 1,400. That's going to equal 1 over 25 multiplied by W being 1,400, subtract 300. That's my slope. You can leave it like that if you want. You don't have to do anything. That's the slope of W at that point. That's the slope of my tangent line. Follow-up question. Like that mess. I'm going to, because I don't want to make a mistake. I just keep going. So let's see, I'm supposed to use the line tangent. So I've got to write down the line tangent now. I'm going to use it to approximate. So let's see, the line tangent is going to be y equals that slope. Or I could probably change that to 1,100, I guess. That's pretty easy. Save some writing. Times x minus the x coordinate, which is 0, plus the y coordinate, which is 1,400. If I do that, I got, let's see, I haven't finished it. I did this just fine. I found that, so I got 1 point. Questions? Keep going. To use the line tangent to approximate the amount of solid waste at the end of the first 3 months, which is when time is equal to 1/4, I just write a new equation and I say, therefore, W of time 1/4 is going to be approximately 1100 over 25 multiplied by the time is 1/4 minus 0 plus 1400. I should put in units because that's my final answer. That's my approximation for W at 1/4. I don't do anything else because I'd risk losing points if I do.
So the actual answer is 1400.
If you work it all out.
Wait, can you just one more time explain the W of 1/4?
So the idea is, Paris, I have some curve W. Okay? I don't have any way to find values of W. So they say, draw a line tangent. And notice that right here, if you stay close to the point of tangency, the y-coordinate on the line is going to be awful similar to the y-coordinate on W. So we're using the y-coordinate on the line to approximate the value on W.
I don't like the actual graph. What it would actually probably pretty close.
Well, for our class, we don't really care whether it is close or not. We just go with their assumption that it is. Not in this class. In other classes, no. I've never had a class that went into that much. In my work, I definitely studied that idea. Questions? So this is like t equal 1/4 right there. So at that spot, have I answered your question so far?
Yeah, I think
So-
I figured it out.
Okay, so this equation is how I can find any point on the red line. So I'm going to find that point. So I plug in t equal 1/4, and that's got to be the y value right there.
So if I were to do clusters and I see to approximate the amount that I kind of automatically assume if I'm drawing the thing to picture and I look back at the equation, that'd be a good thing to say that I'm going to use the equation of the tangent line to approximate.
Yeah, that one I can give you, hey, for sure, listen. So you can make a flashcard for that one. Whenever they say use a line tangent to approximate something, you're always going to create the line tangent, and you're just going to plug in and use it as your approximate. That's what you always do. Rachel?
Okay, I'm gonna try and word that again. But so dW over dt is the derivative of W, correct? Isn't that, isn't it also, it's also the tangent line to W, isn't it?
No, that's a common misunderstanding. So we have a curve W, we have a line tangent. The line tangent is this equation. This equation is how you find the slope at any point on W. So it's never the line tangent ever. It's how you find, here's the problem. We talk about this using too few words. If we throw in a few more words, it clarifies the situation. So what this really is it's a formula for computing the slope of any line tangent to W. So it's never the line tangent to W. The line tangent to W is this equation, and that can be applied to any line tangent, but that's always the line tangent equation. This is always how you find the slope of any line tangent to W. That helps?
Yes.
Too complicated. No, that part you have to memorize. What it says is that because W satisfies this differential equation, you know by that this is the equation for finding the slope of W at any point. That's what the words mean. So it's no different than me saying, why does it make sense that this is called a table? Only because somebody told you this is called a table. So I'm now telling you that when they say W satisfies this differential equation, that means that if you take the derivative of W, you get this equation.
All right, I'm going to record you saying that.
I'll do my best.
Exactly what you
Okay, so when they say W satisfies this differential equation, that means that if you take the derivative of W, you will get this. Okay, that's true of, hey, look, it's a general mathematical principle. Look over here, look. You tell me, what is the value of X which satisfies this equation? Go ahead. 3. So the value of x that satisfies this equation is 3. The equation for w that satisfies this equation is the equation for w, and if you take that derivative, you get this. That's what it means to satisfy. Make it true. That help? Perfect. So you got it.
So, if you take the antiderivative of that, you get the equation W?
Because this derivative contains an output variable, we cannot just take an antiderivative. If, however, we use the method of separation of variables to solve this differential equation, we get the equation for W. Absolutely. Anybody else? Please, like.
Okay, so where it's the dw over dt at w of 1400, why do you use the 1400 maybe rather than the 0?
Gotcha. Because
that's what it is?
let me say it back to you. If I'm wrong, you keep talking, okay? I think I know what you want. If I'm wrong, you keep talking. This equation for finding the slope of W at any point, like I said to Rachel, right? I can use this equation to find the slope of W anywhere. Requires me to know at what point on W am I looking at. Well, I'm looking where W is equal to 14 and time is equal to 0, for sure. But the equation requires you to know the value of W. So that's what I have to plug in. Did I answer it? You're used to derivative equations that more commonly would require you to plug in the value of t. But it doesn't change the fact that it's still just an equation, and you plug in whatever it asks for.
Okay, so that's not something that's
right.
Why it's
whatever you're given. Just whatever you're given. It's a really good example of, again, understanding the concept, not the problem, right? The concept is I have an equation for the slope of W, plug in whatever I need. Good question. Anybody else? You guys, hey, look here, everybody look. You are doing supremely well. It's April 10th, test is on May 15th. You're doing really, really well because you are focused on how do I just work my way through an unknown problem. That's where your focus has to remain. You don't shift to, oh my gosh, I got to memorize all these different practice tests. No, 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 no. Every time I give you a practice test, it's brand new. Just get better at working your way through it. Then you'll do just fine on May 15th. Okay, are we good here? Keep going. RB. Find the second derivative in terms of W. Period means stop and do it. Don't read more. Just stop and do what they ask. Here's the first derivative. Second derivative is easy. 1 over 25 is a multiplying constant. So it's a constant factor. Just write it down. Okay, two things subtracting. This derivative will be 0. This will be dw over dt. But I'm supposed to write the answer in terms of W. So I make a substitution. In place of dw dt, I put in what dw dt is. I'm done. Stop right there, I earned the point. No guessing, no brainstorming, just do the work. Question? Please. It's not.
I just don't know, like, how do you know when to stop? Like,
When to stop? No, it's a great question. 4 pebbles, Reagan. Key things are these. Always stop on the periods for sure, so that you're not kind of mixing in other things. So right here, I just go careful. You're supposed to find the second derivative, read slow, in terms of W. So that, you're talking.
Like, how do you know, like, I just stopped it with the one.
Right here.
Yeah.
It's totally fine. It's totally fine. That's why we do practice tests, so you get used to their language. Okay, this is the second derivative in terms of the first derivative.
Okay.
Because this isn't W, this is dw dt. Just read the name for me, because I can't see it. You're okay. Wow, that is hard to read. I'll figure it out. Thank you. That says parents of somebody that knows. There we go.
Solid one, Nicole.
Good work. I don't have my glasses. I didn't put them on, but that was pretty good. All right. Hey. So this is in terms of dw dt. This is now in terms of W.
Okay.
Now, hey, stop here though, because Reagan, if I were to do anything else, all I'd be doing is multiplying and dividing and subtracting. Okay, when all that's left to do is multiply, divide, add, subtract, square root, exponentiate, stop. You don't have to do it.
And they don't care about exponents.
This is great.
So
Full credit.
you gotta do to get that to the point, not just the these for the.
Yeah, this one wouldn't work. The point is the box. Now, if you multiplied it out and got this, that's also a point as well. But you don't have to do it. This is fun. Just stop there. I would say stop here. Don't take a chance at making a mistake. Plus, it takes more time. Plus, you relax more. Your brain's not all focused on all this adding and subtracting, which you don't need to know for this test. Just stop. There you go. Okay, now I keep reading. Use the second derivative, here it is, to determine whether my answer in part A, my linear approximation in part A, my tangent line approximation, is an under or overestimate. Okay, right there, my brain is, memories are flowing forward. I'm thinking, okay, this is memorized fact. The tangent line approximation, if the curve I'm approximating is concave down, so here's W. If the curve is concave down, then my tangent approximation will always be an overestimate. You can see it. All the points on the tangent line are above the curve. However, if the curve I'm approximating is concave up, then the tangent line approximation will always be an underestimate. So all I have to figure out is whether the curve I'm approximating is concave up or concave down. You need me to restate that fact. That's the memorized fact, and visually is the easiest way to memorize it. The curve I'm approximating is concave down, tangent line will definitely be above. The curve I'm approximating is concave up, tangent line is definitely below. Danica's chart says if the second derivative is positive, curve is concave up. Second derivative is negative, curve is concave down. So let's see, values of W. Supposed to go, let's see. So we start with 1400. So at the beginning, 1400, this would be positive. Models the amount of solid waste. It says W is increasing. Oh, there we go. W just increases. So this starts at 1400, never goes down. So this is always positive. So just write that down. Since, you write Sims, I think they'll forgive it. Since W of 0 equals 1400, and W of t is increasing, therefore, second derivative is positive. So, W is concave up. You can abbreviate. So, the approximation is an underestimate. That's the point for the reason. Dave?
So I just said since at time equals 1/4 is positive, the amount of waste.
Maybe. I'm not sure if you have enough or not. Anybody else? Please. As they told me, at time 0, the landfill contains 1400. W at time 0 is 1400. So this starts at 1400. And from there, W only gets bigger. So there's no way for the second derivative ever to be negative. Stop, Spartan. Please, like.
Okay, this is quick, but so if it was concave up and concave down, would you just have to find like at like 1/4 which one it was?
Yeah, you would, but they never given a question like that because I think it's beyond the complexity they want to test you on.
Okay.
But that logic is correct. Well done. Yeah, they've only given questions where the curve is either concave up or concave down. Cool, next one. Okay, it says find the particular solution. This is Suganda's comment right here. Find the particular solution W. So you have memorized that the solution of a differential equation is the W. That's what we're looking for. You've also memorized the steps as to how to solve a differential equation. We practiced it before. So here's my differential equation. Must separate the variables first. I don't like fractions, so I'm going to move the 25 over here. Move the dt to the other side. Questions to there? I have to get the w on the left, so I move all of this over. So I end up with 25 divided by w minus 300 dw is simply dt. Please.
I left the 1/25 on the other side of that line.
Mhm.
Okay.
Yeah, being a multiplying constant really doesn't matter where you put it as long as algebraically you don't make an error. It's totally fine. Anybody else?
Oh, and you set that solution of the equation of the the equation. I don't know. So it's like basically saying y equals the equation. The solution to that equation is y. Basically, the same thing. That makes sense now that the slope is any line that you get from through. So that's what.
Let me do further, I'll say it back to you. I'm not sure you're saying that right. You know that. Suganda?
So I just didn't know what you read in that. So I didn't realize that you were supposed to do the.
Yeah, it's okay. It's back to the, hey, really it's back to the comment about the table. You just have to memorize the meaning of the words. When they say find the particular solution W of the differential equation, that's how they are saying, this is the derivative of some formula. Please go find the formula. You simply have to memorize that that's what those words mean. Find the particular solution to the differential equation means go find the formula for W. And you must also memorize that that process is this acronym. Separate, anti-differentiate, constantate, isolate. That's how you always do it. So, let's see. Yeah, the 25 is just a multiplying constant, so you can put it wherever you want. So this is what Bailey had. She had, when she goes to do the antiderivative, she'd have 1 over w minus 300 dw equals 1 over 25 dt. That's totally fine. This is one point to get to here, or here, either one. Now I do the antiderivatives. This is the ln rule, but it's ax plus b. So it's 1 over a, 1 over 1, natural log, absolute value, w minus 300, equals 1 over 25t, plus a constant. Okay, I'm going to finish this after the bell so I can get my video. At the start of class, like on Thursday, we're going to, Thursday, we're going to grade this, but we'll finish doing the FRQ first. Then we'll scan, then we'll put in your scores. So let me finish here. When the bell rings, you can leave if you want to. So that's another point. Then I want to find the constant, so I use this information to find the constant. So I get natural log, absolute value, 1400 minus 300 must equal 1 over 25 times 0 plus c. So C is the natural log of 1100.
Focus. I don't want to read all these names again. It's Hayden and Lowe. Stephen
That
Lane.
gets you, hey,
JP Leary.
that's 2 more points.
Fuller. Kate.
If you want to stop there and not do this, fine.
Samantha.
Just, you got 4 out of 5.
Emma Cuddy. Isabel.
But now to isolate W,
Brevin
we would
McCullough.
say, okay,
Monet Benson.
right here, natural log,
Callie Ross.
absolute value of W minus 300.
Leah Collins.
How many people?
And Sierra.
Equal to 1 over 25T plus natural log of 1100. Take both sides of the equation, make them an exponent of E.
I wrote an equation for this guy. You were awesome.
5 points
I scored for what?
over both of them.
I don't know, but I had so many questions, I got some pebbles, so that was happy.
I'm coming out.
I don't know, he said like he didn't know if he was doing it today, but I was. Actually, no, I knew his hat.
Sometime this week I'm
You don't need the absolute value because you know that W is always 1400 or greater. So you can drop those.
When you don't have.
Yeah, because you have to isolate W.
That is specific.
Very 1 second.
Jesus. I'm still on my here. Ego. What? Oh, you said you just went with water. Did you hear? You can see Senior was text. It goes through the middle of them, and it